So I'll now add a flow entry to table 1 with a priority of 20,000. And I'm going to match all traffic coming in on port 1, and we're going to dump that traffic. So I'll click Add. Notice table 1 has a flow entry of 20,000. Does that affect my pings? In this example, we lost 1 ping, but notice the pings continue. So this flow entry is not affecting the forwarding of traffic because it's the second table in the OpenFlow pipeline and no traffic is being forwarded from table 0 to table 1. However, if I added a flow entry to table 0 with a priority of 20,000 and said that traffic coming in on port 1 should go to table 1, let's see what happens now. So I'll click Add. So notice we have hits on this new flow entry, and we now have hits or matches on table 1. And notice the pings are failing. So the logic is as follows. First table in the pipeline is table 0. When traffic arrives, the switch looks for a match. In this case, we're looking for traffic coming in on port 1. So we've got this entry, and this entry that match traffic coming in on port 1. However, because this has the highest priority, 20,000 of the 3 possible matches, it's the one that's used. So the traffic is then forwarded to table 1 because of this go to table statement. In table 1, the matching process starts again. So in table 1, do we have any matches for traffic coming in on port 1? And the answer is yes, we do. This flow entry matches traffic coming in on port 1 and dumps the traffic. So hence, the pings fail. If I deleted this flow entry, would the pings start succeeding? And the answer is no. By default, in OpenFlow 1.3, if there are no matches in a table, the default action is drop. So when traffic arrives on port 1, it gets matched based on this flow entry in table 0, the first table in the pipeline. Because it has the highest priority, it's used to forward traffic to table 1, but table 1 doesn't exist. In other words, there are no matching entries in table 1, so the traffic simply gets dropped. If I, however, delete this flow entry, we should see the pings succeeding, and there you go, because it's now being matched on this flow entry. So it's important to realize that OpenFlow tables with numbers higher than 0 are not used unless a go-to statement is used to forward the traffic to those tables. As an example, I could add an entry to table 0 with a priority of, let's say, 20,000, saying traffic coming in on port 1 should go to table 5. And then I could save the flow entry. Table 5 doesn't exist, so the pings get dropped. I could also create a entry in table 0 with a priority of 30,000, matching port 1, and I could send this traffic to table 9. So which one's going to get matched on? Well, it's going to be the highest priority entry, as we can see here. So the top entry is being matched on. Pings are failing because table 9 doesn't exist. But if I added a entry to table 9 saying that traffic coming in on port 1 should go to port 2, we should see our pings succeed, and there you go. Our pings are starting to succeed because in the pipeline, the first table is used, which is table 0, which now sends the traffic to table 9, and the traffic is then processed based on table 9. So for traffic arriving on port 1, so in port 1, this top flow entry with a priority of 30,000 is used because it has the highest priority, and traffic is forwarded to table 9 to be processed. In table 9, the process is repeated, And in this case, a match is done on traffic coming in on port 1, and the traffic is sent out of port 2. So our pings are succeeding, and if we refresh the flow entries, we can see the hits for traffic coming in on port 1 matching this flow entry, as well as matching this flow entry. But traffic coming in on port 2 matches this flow entry here. So when traffic arrives on port 2, the switch starts at the first table in the pipeline, which is table 0. It doesn't match this, but it does match this, and traffic coming in on port 2 is sent out of port 1. When traffic comes in on port 1, it could match this, it could match this, it could match this in table 0. Table 9 is not used initially. All matching is done on the first table in the pipeline, which is table 0. This entry has the highest priority in table 0, so the action applied is based on what is set here, which is to send the traffic to table 9. In table 9, we repeat the process, so we're matching traffic coming in on port 1. If the traffic does arrive on port 1, it's going to be sent out of port 2, and that's what we see taking place here. So in summary, in the OpenFlow specification, we are told how traffic is matched, and you can find that by looking at the OpenFlow specification itself. I'll look at 132 because that's the version used by the HPE controller. And in this example, the switch has negotiated to use OpenFlow 1.3 with the controller. In this document, the OpenFlow pipeline is explained. When a traffic arrives, it's first processed based on table 0. It can be sent to subsequent tables for processing, but that only takes place if you have a go-to statement such as this. So based on table 0, this flow entry has the highest priority, and that's what's going to be matched on traffic coming in on port 1, and then the traffic is sent to table 9 for subsequent processing. So in the OpenFlow pipeline, you can have either a single table, table 0, or you can have up to 255 tables. That is dependent on the hardware of the switch. The Zodiac FX supports 10 OpenFlow tables numbered 0 to 9. You have the ability to use go-to statements to determine how traffic flows through the OpenFlow pipeline.